Hey there, today we'll be solving the third set of the NumPy exercise, which is somewhat based on the last topic that you learned, that is broadcasting. You'll find a couple of questions based on that here. Also, you might learn something new, you might get to revise some old concepts. So just please stick to the end and solve them, and I'm sure you'll feel confident enough. So let's get started. Here's your first question. You have this NumPy array. What you need to do is print the array of odd rows and even columns from this given NumPy array. Got it? Now, come on, you can do it. Alright, supposing you all are done, here's your solution. You have the original array given to you. Let's say, just for simplicity's sake, I'm going to print out the original the original array. And next what we're going to do is this slicing out here. What do we need? Odd rows, right? So you obviously start from number 1. Now there might be a little bit of confusion, but let's go ahead and print it, then I can explain it better. What I have considered here is odd rows, right? So I have considered this as row number 0. If you would have considered this as row number 1, then you would have written 0 in this case, right? And similarly, I've considered this as column 0. So 0, so I should basically be getting odd rows, that is, let's say 24, this row and this row. And from these two rows, I should only be getting the even columns, that is 24, 32, 56, 64, and that's what we've got. Pretty simple, right? Just slicing concepts. Let's move ahead. Your second question. You have two NumPy arrays and you have to calculate the cube roots of the elements after, let's say, adding them or multiplying them, any of that. I didn't put that in the question, but never mind. You can be creative and go try that out. Okay, so did you get it? And did you sense some similarity of broadcasting concepts here? Both the arrays were of the exact same shape, so there shouldn't be any problem after applying any arithmetic operation on that. So I've just taken a simple addition going on. And here is your cube root function that NumPy has ready for you. Let's go ahead and run that. There you go, no issues. You can give any random number a cross check. Let's say add 17 and 7, giving you 24. And go ahead and find the cube root of that if it gives 2.88. Okay, second last question. You need to create an integer array and display only those numbers that are divisible by 3. And your time starts now. Alright, considering you do not know about the where function of NumPy, as I had told that you might just learn something new, here's something new. What you do is simply use the where function, which takes in a parameter, which is the condition that is to be satisfied by the array elements. So you have array mod 3 is equal to 0. Now, like in Python, okay, NumPy is also part of Python, but in normal Python coding, you would have to apply a for loop or any sort of looping, right? You don't have to do that here. We had seen this long before in our first NumPy video, that it just gets automatically applied to each and every single element. Again, a concept of broadcasting. Let's go ahead and run that. There you go. You also had the data type being printed here. And that's it. We're done, right? 0369, all divisible by 3. And here's your last question. Show if A multiplied by B is possible, where A is this NumPy array and B is this NumPy array. Give it a slight thought. Maybe you could just work it out on pen and paper and come back to it. Alright, I really hope you all got this, because again, this is broadcasting. If you've seen my previous video or maybe you already know about broadcasting, then you shouldn't be having an issue. But for those who have a slight bit of confusion, here's your solution. I will just try and visualize this out for you before getting the output for you. In the first array, you have 5, 10, and 15 arranged in such a way that there are 3 rows and only 1 column. So after you try and print out A, this is what you're going to see. 5. Then in the next row, you have 10 and then 15. All right. And For the second one, you're going to have in the same row 10, 11 and 12, right? So, do you think this can be applied? Of course it can, because this is 0, or let's say you apply 10 to 5 and 10 to 10 and something like that. Now let me go ahead and remove, or let me just comment this out so that we can see this later on if we need it. Okay, now let's go ahead and run that. There you go. This is your broadcasted array. Okay, NumPy array. First you have 50. So what did you get? 5 into 10. Pretty good. Next you have 55. That is 5 into 11. Next you'll have what? 60. 5 into 12. And that goes on for 10 into these 3 numbers. Then 15 into these 3 numbers. Works pretty well. And that's pretty much it, right? Okay, let me just go ahead and remove this because it just comes and confuses us. Alright. Okay, all neat and clean. Okay, I hope you all got it. This was a simple exercise, but might just revise your concepts. And I'll meet you all again next time with a few other concepts of NumPy. Till then, bye-bye. See you soon.